Hey, what's up, everybody? It's Chris, and today we're going to be talking about YOLO-NAS, which is put out by Super Gradients. Straight up off the bat, I want to say that this is an incredible tool. The video that you're about to watch is definitely a little bit memey, so forgive me. I didn't want to take it too seriously. There's a ton of serious content about this algorithm right now, but it's May the 4th, and so we're going to play with that theme. Genuinely, though, the work that Super Gradients has done is amazing. Please don't let my joking around detract from how incredible the tool is. Enjoy the video. If only there was a way we could detect reliably what scenes Jar Jar Binks was in so we could avoid watching them. And you know what? Super Gradients comes to the rescue. So as you see, in this scene featuring what can only be described as an amalgamation of labels flicker between horse, cow, dog, person, horse. I mean, it's just not sure what Jar Jar is. Okay, so we've got to teach the model. And that's where this notebook in Super Gradients comes in. Okay, so I'm going to link all of this stuff in the description below. The notebook itself is fantastic, but in order to solve the problem here, and the problem is we don't want to have to watch Jar Jar, okay? We unfortunately have to spend some time looking at Jar Jar because we need to create a labeled, annotated data set in which we draw boxes on whatever Jar Jar is supposed to be's face, okay? So as you can see, we have a tremendous number of images here of Jar Jar where I've labeled him. Each one more hideous than the last. So I want to be clear. My labeling is kind of bad. So my annotating is not ideal. So I'm inconsistent. Sometimes it's just the face. Sometimes it's his whole strange body, but what matters here is that we've got about, 100-ish annotated images of Jar Jar. And I got to tell you, I had to draw these boxes manually. All right. But we did it. We did it because it's worth it. And I did it so you don't have to, all right? Now, once we have that, we just need to put it into our drive with this, pattern. So we have our data folder and then our training data and our validation data. Now, you will notice that in the training data set, we have both the images and the text. And these are called YOLO annotations, which is basically just saying what class this is and then where do the bounding boxes corners live, okay? And that's associated with this image. And that's it, to be honest with you. That's the amount of work that I did to prepare for this. Let's get rid of that. We don't want to have to look at Jar Jar more than we need to. So all I did was mount my drive, make sure that I had some persistence between sessions. And then we head down to setting up our data set. So the video we saw where it was struggling to label Jar Jar. Here we have him as a dog. Here he is a person. It's pretty confident he's pretty confident he is a horse. Now he's pretty confident he's an elephant. I mean, this is what we're dealing with, right? The base model doesn't have a good understanding of what Jar Jar is, so we've got to teach it. Again, I know we're kind of joking here, but this is an incredibly impressive piece of technology that's been released here. It is fantastic. It's lightweight. It's easy to use. So huge props to Super Gradients. It's May the 4th, so we got the Star Wars theme. We're kind of joking around, but it is genuinely an amazing piece of tech. So that was with the base model. It's not good, right? It basically doesn't have any clue what Jar Jar is, and so we can't reliably detect when he's in the scene or when he's not in the scene. So let's head down to where we set up our data set so that we can fine-tune this model and get a little bit better at detecting Mr. Binks. So first things first, we just set up our checkpoint directory. Again, if we look in our file system, this is just set to be right here. Perfect. There you go. And then we head down to our data loader. We're going to actually skip this RoboFlow piece because we're not using RoboFlow. So we do need to import these data loaders that are provided by Super Gradients. Truthfully, this was like the most seamless experience I had out of the box with any library. I did nothing. I promise you, the amount of work I did was draw boxes around Jar Jar Binks' head. I went over here to actions. I hit export annotations. I included zip package containing files in YOLO format. And then I just manually moved them from where they were into the training and validation folders. That was it. Next, we have to set up some directories. The only piece to make sure of here is that when you have your data directory, your train images directory is going to be appended onto this. So just make sure that you don't path directly to this more than once. Classes is Jar Jar. Now, technically the class is 0. So again, if we go back to our drive and we go to our data and we go to our training set, let's say, and we look at the text file, you'll see that the class is 0. Again, with no extra work, Super Gradients knows that that's the 0th class, and so it calls it Jar Jar because I've asked it to. I cannot stress enough, as much as a meme video this is, very easy to use, very wonderful tool. Okay, next up, we just create our training data loader and we create our validation data loader. Again, it has everything set up for us. You don't have to change anything or manipulate anything. It's easy enough. We just click play and it goes. Okay, so this is pretty interesting. Basically, Super Gradients automatically augments the data set. And, we wind up with this data set of very interestingly, positioned and tilted, rotated, translated, everything. Many Jar Jars, a few Jar Jars. We've got all the augmentations. Basically, we want to make this task as hard as possible during training so that we're learning how to really accurately predict, where Jar Jar is in the image. Also, some of these, just looking at this kind of makes my stomach upset, just given how haunting some of these images are, but that's neither here nor there. Next up, we instantiate the base model. We're using YOLO-NAS L, which is the large version of the model, because why not? As you can see, I used only 18 gigabytes of GPU RAM during the entire process, so very lightweight. Good job, Super Gradients. And this is, again, for their large model. Now we can set a bunch of parameters. I didn't fiddle too much with this because I didn't want to go too out of the way. I did just jack it up to 100 epochs, just let it run for a while, give it the best shot. But otherwise, these are all provided in the notebook, and there's a lot of really good information. The documentation is fantastic for this tool. So if you have anything that you want to look for or look into, I would definitely do that. Again, this is a fantastic tool, both in terms of the performance and also how easy it is to use. All right. And next we train. And you .train. Can't get easier than that. I really like this UI that they have that shows you kind of, what metrics are doing what relative to what other things. I love that I get to see what my best overall is and what the last epochs was and what the current epochs is. It's just a really, really slick UI for monitoring training. And if you wanted to sit here and watch it, you could do that. Wouldn't suggest it. Is going to take a while to do 100 epochs, but that's totally fine. The UI is great. The next piece is getting the quote-unquote best model. Now, we're not actually getting the best model here. We're getting an averaged model, so we averaged our weights across training runs. You could use the best model or the latest model. Totally up to you. I found that the average was fine, and so I didn't feel the need to change it. Now we get to test it, and by gosh, does it detect Jar Jar. So we feed it this image, and we get a relatively confident prediction of our favorite dog, horse, elephant, camel person. Now, all that's left is to actually run this thing on the original video with the new model, which I have, of course, already done. And I think you're going to be surprised by how good this really is. All right, here we go. Look at that. Clean Jar Jar predictions. It's a bit spotty, but once we move scenes, look at this. Look how confident it is there's a Jar Jar in that scene. Truly amazing. Again, this is with 100 epochs, right? This is with the world's worst annotation ever. There's something like 96 images, and I think only maybe 60 of them were annotated, and they were not annotated well. And still, YOLO-NAS has absolutely no problem keeping up. I got to be honest with you. I was expecting this to kind of be silly or okay, we'll find Jar Jar. But it really nailed the task. And again, it's not great if Jar Jar is in a weird position or, if he's not facing the camera, if he's far away. But when we see his face, we get pretty accurate Jar Jar results. And check out this scene here, right? Look at all these other poser Jar Jars that don't get detected. Look at this. That's incredible. There's like a frame where it misattributes Jar Jar. I mean, again, this is with 100 epochs with the worst data set conceived. And it's really pretty good, to be honest with you. Look at this. He's right next to another Jar Jar looking creature. And it's like, nah, dude, that ain't Jar Jar. So there you go. So I know this was kind of like a sillier video. It's May the 4th. Just wanted to put out something light today. And, you know, if you like Star Wars, that's great. If you don't like Star Wars, you know, well, I hope you like object detection algorithms, because this is basically the best one out right now. I think, you know, in terms of both the metrics that they're achieving as well as the compute necessary to get those metrics, I couldn't recommend a different object detection algorithm more. But with that, you know, I hope everyone has a great day. Hope you enjoyed your time today, and may the 4th be with you.